There's a gentleman in Montana, I understand, that had some research that really spoke to what AGROTAIN's been talking about all along, the nitrogen loss, as it relates to cold temperatures. Share that story with us.
Well, it's kind of funny that Martin's with us today, because Martin came to me several years ago and wanted us to do some research on cool weather volatility. So we did some university research. We went to Auburn University. Elizabeth Girdle with Auburn did some cool weather at 50 and 45 degrees. We then went out to private industry and had them do it. And all of a sudden, another colleague calls us from out in the Pacific Northwest, a man by the name of Jeff Perotti, and he goes, "John, have you heard about this researcher, Dr. Rick Engel at Montana State University?" And I said, "No, I haven't." He says he's studying our product, looking at cold weather volatility, and they're seeing volatility losses as low as 30 degrees.
What, is that right?
Yes, incredible.
So we have a video we want to share with you from that you brought with you for us to share with viewers tonight from Dr. Engel in Montana. Let's take a look at that and some of his research in cold temperatures.
Over the last few years, as fertilizer prices have become increasingly unpredictable, thousands of farmers have learned about the costly potential of nitrogen losses from urea into the air, known as volatility. While many have learned how to protect against those losses, saving money and boosting yields in the process, misunderstanding persists about when and how this volatility occurs, leading others to believe they are protected against nitrogen-robbing volatility when they indeed are not. That's what led Rick Engel, a soil scientist and associate professor at Montana State University, to establish his research into quantifying ammonia losses from urea applications made to no-till wheat in his state's cold climate.
This question about ammonia volatility from surface applications of urea, it's been, we've been asking it in this country for really decades. And I began working for Montana State University back in 1983, and we were asking that question back then. The issue of cold weather volatility has come up, and there's always been the belief that we can minimize losses of ammonia if we just apply urea fertilizer in cold weather. What we've been seeing actually is some very large losses, even when the soil temperatures are near freezing.
To start, Engel chose locations with some of the coolest temperatures in the continental United States, near the Canadian border in northern Montana. In each test field, he established 3 separate circular measurement plots and utilized unique custom-built instrumentation to measure ammonia losses.
Well, one of the big project objectives of this study is to look at ammonia losses, and specifically we want to know just how much of that urea that we apply to the soil surface is lost as ammonia. And to do that, we're utilizing this micrometeorological approach that I have standing behind me. It's a mast, and it's configured in the middle of these circular plots. And in the mast, we have these shuttle devices, or traps, which are there to collect ammonia that's coming off the soil surface.
To compare this outgassing from the field in varying situations, Engel creates 3 circular plots in each location, one with urea alone, another with urea protected by AGROTAIN, and a third left unfertilized.
What we have is this system. We're working with a center mass that's behind me, that's situated inside of a circular plot. And our circular plot is 20 meters in radius, or 40-meter diameter circle. And what we do is we fertilize the area inside of that circular plot. We did that about a week ago. And as that urea undergoes hydrolysis, it's converted to ammonium carbonate and becomes susceptible to volatility losses, we're able to trap that ammonia with those shuttles. We're trapping the ammonia, we bring it back to the lab, we wash out the ammonia that's trapped in that shuttle. And of course, when we come out here and swap out those shuttles, we've got another set of shuttles that have been recharged to replace them. So what we're doing with this system is we're doing continuous measurements of ammonia that are coming off of those circular plots.
And the outcome? Well, while Professor Engel's research is ongoing, his first 5 campaigns have yielded very interesting results that definitively demonstrate significant losses of nitrogen from urea applied during cooler temperatures.
We've conducted 5 campaigns to date, and our losses have varied everywhere from 3 up to 40%. Our highest volatility losses have occurred where we've had damp conditions at the soil surface for prolonged periods of time, but without any accompanying rain that was sufficient to really move the fertilizer into the ground where it's no longer susceptible to volatilization. During some of my earlier campaigns, we've actually applied nitrogen fertilizer on top of a ground which had a trace of snow, and we actually have seen losses of up to 22% of nitrogen coming off as ammonia during the first week. And this is because we had prolonged damp conditions, which seemed to be very conducive to volatility losses.
In fact, in one such campaign, a comparison between the unprotected and AGROTAIN-protected plots in the crucial 2 weeks following application showed a distinct difference between the two, indicating a substantial loss of nitrogen from untreated urea and a considerable validation for the AGROTAIN.
Well, what we're finding with AGROTAIN is it's giving us 2 weeks of protection from volatilization losses. And over an 8-week campaign, we'll see a reduction in the amount of ammonia lost, or amount of urea lost as ammonia, and the protection amounts to about 60% over an untreated product.
Now that Professor Engel has completed his initial studies, he's continuing his research with more winter campaigns. In the meantime, thanks to the research of Rick Engel and Montana State University, growers in North America now have more data with which to make their fertilizing decisions in cool weather conditions. In any case, they have yet another situation in which AGROTAIN can help keep nitrogen going to their crop instead of up into thin air.
I think there's always been this belief that ammonia losses from urea will be minimized if we're applying urea when in cold temperatures. But it's been surprising that we've seen some of the largest losses when our urea applications are applied at around freezing.
Wow, comments there from Dr. Rick Engel from Montana State University. Boy, just seeing that country, beautiful country out there for one thing, and wow, that had to be just a gold mine for AGROTAIN, but it obviously some very concrete evidence that cold weather does not stop the urea volatility.
That's absolutely right. And you know, the last statement that Dr. Engel said, who, by the way, is an incredible researcher.
Sounds like it, yes.
Dr. Engel said, we always thought cold weather would minimize loss. And his study has shown no, it doesn't. And I'd just like to say something. We've talked about a long time that don't be afraid to put your urea down if it's freezing outside. We've talked that because that's the level of knowledge that we had. But this type of instrumentation that he's using has brought a whole different meaning to what happens out in the field. The instrumentation is from Australia, adopted by the USDA Agriculture Research Service as their standard protocol for field collection of ammonia volatilization. And Dr. Engel has taken that and has shown that it's not weather, it's moisture that is the culprit.
Yeah, that's really the bottom line of it all. Moisture is the key, and as we've talked, moisture really is unpredictable.
That's exactly right. That's exactly right.